So we're going to do the sequences problems. Now, pretty much all Core 1 Edexcel sequence problems come down to deciding whether the question is about the nth term, in which case you're going to use this formula. The nth term is a plus, pardon me, n minus 1d. Or if it's a sum problem, in which case you're going to use this formula, the sum of n terms is n over 2 multiplied by 2a plus n minus 1d. So, looking at question 1, we've got the girl saving money over a period of 200 weeks, so we know that instantly that we've got a, d and n, so n is going to be 200 because that's the one we're interested in, the 200th week. We know that the first term a is 5p. We know that the common difference d, well, it's going up from 5 to 7 to 9, so it's going up in 2's. And the amount she saves in week 200, this is an nth term problem. So we just substitute it in. So the 200th term is equal to 5 plus 199, that's n minus 1 times d. And 199 times 2 is 398, and we're adding 5 to it, which gets us to 403, and it's an amount in pence. Next question is very similar. Calculate her total savings over the complete 200-week period. So remember again, A is equal to 5, D is 2, and N is again 200. Only this time it's total savings, and that means we're going to use the sum formula. So we want the sum of the first 200 terms, and it is N over 2 times 2A plus n minus 1, that's 199, d. And then we just evaluate that. 200 over 2 is obviously 100. 2 times 5 is 10, plus 398. And that is 100 times 408, which is 40800 pence. There we go. Easy marks, isn't it? Okay, a little bit trickier here maybe. We've got to work out the nth term of this sequence. So we have a little think about that, and we've got to work out, write down the first 3 terms. So this tells us how to do it. So the first term is 2 times 1 minus 5, which is minus 3. It's going up in 2's, so you can see it's going to go to minus 1 and then 1. Value of the common difference, well, it's going up in 2's, so d is equal to 2. Okay, show that the sum of the sequence of n terms of this sequence, which is the sequence we've been given, is equal to this. So we're going to use the sum formula here. So the sum of n terms is given by n over 2 times 2. Now a, we got a, the top a is minus 3, so it's 2 times minus 3 plus n minus 1, and we got d in the previous part as well. D is 2, it's going up in 2's, n minus 1 times 2. And then we just rearrange this until it turns into that. So we've got n over 2 times minus 6 plus, and I'm going to expand the brackets, 2n minus 2. There we are, which is n divided by 2, and then minus 6 and minus 2 make minus 8 plus 2n. And then if I expand the brackets, I'm going to leave the n outside, but I'm going to take the divide by 2 in, and that gives me n multiplied by minus 4 plus n, which of course is equal to n times n minus 4, and we've finished that, we've shown it QED. Okay, slightly harder question maybe. harder for a variety of reasons. So Alice on her 11th birthday, so that is the first term. So on her 11th birthday she started to receive an allowance. The first one was 500, and on each following birthday the allowance was increased by 200. So we know that the first term is 500. We know that the common difference D is 200. Show that immediately after her 12th birthday the total of the allowances Alice has received was 1200. Well, the first birthday was 500, the second birthday was 700 because that's the next term in the sequence, and that makes 1200, and of course it's pounds. Only one mark, don't expect to have to do much for it. Now, on her 18th birthday, so this is, on her 18th birthday, this is an nth term. It doesn't say total in here, so it's not about the sum, it's actually it's a specific term in the sequence. So we're going to use the nth term, which is a plus n minus 1 d, pardon me, and we know what a is, it's 500, plus, be careful with the n here, on her 18th birthday, 11th was the first one, 12th is the second, and I think you can probably see from that that the 18th is the 8th in the sequence, so n is 8, so it's 8 minus 1, and of course d was 200. Pop that there. A is 500, and d is 200. Be very clear about where your n, a, and d are. So then we've got 500 plus 9 lots of 200, and that's 500 plus 1800, which is my bad. Good job, I've been looking at, spotted that. It's obviously a bit late for me tonight doing it. So that's obviously 7 times 200, which is 1400, which gives 1900 as her 18th birthday present. Very nice, isn't it? Now, C. Find the total. So this is a sum problem. Up to and including her 18th birthday. We already know that 18th birthday n is 8. We know that a is 500 and d is 200. So it's the sum of 8 terms, which is 8 over 2 times 2a. So 2 times 500 plus n minus 1 times 200. Which is 4, and then inside the brackets goes 1000 plus 7 times 200. So we've got 4, and then we've got 1000 plus 1400, which is 4 times 2400, which is 9600. Okay, now again it's a total problem, so it's another SN. Total of the allowances Alice had received reached 32,000. So we know that the total is 32,000. We know what N is. We don't know what N is actually. We do know that A is 500. We do know that D is 200. So this is using the sum formula, and we're going to rearrange it for N. So let's go for it. So we've got 32,000 is equal to, Sn is equal to n over 2 times 2a plus n minus 1d. And we've got n over 2, and then that's 1000 plus 200n minus 200, which gives us n over 2. 1000 minus 200 is 800 plus 200n, and 32000 is equal to 400n. So I'm multiplying this out, so 800 times n over 2 is going to give me 400n, and then that times that is going to be 100n squared. Instantly going to divide through by 100, so that renders it considerably simpler. So that gives me, I put 0 there, so I'm going to have n squared plus 4n and then minus 320. And at this stage, we have now got a quadratic. We've got ax squared plus bx plus c equals 0. And be on the lookout for that, because that is a standard piece of, well, at core 1, but indeed A-level, it'll turn up all over the place. So we're going to solve that, preferably by factorising. And does it factorise? Let's have a little brief think about that. So, 320. If you think about 320, it's 32 times 10, too far apart. It could be 20, and we'd have 16. 16 and 20 looks like we could get a 4 out of them, so it does look like it's going to factorise. So let's have a quick go at factorising it. If you can't see the factorising quickly, you would go for the quadratic formula. So I'm thinking it's going to be plus 20 minus 16. So those two 16s are 32 with a 0, so that gives me that. Plus 20 minus 16 gives me my 4n. So there's two solutions. N is equal to minus 20, or n equals 16. So this one is clearly ridiculous. Why is it ridiculous? Well, n being minus 20, given the first term was on her 11th birthday, that would make her minus 9 when she got this much money, which is obviously absurd. So that's our solution. So n is 16. Given that the first term is on her 11th birthday, this would imply that she is 26 years old. There we go. Okay, question 4. Right, trickier one this. Lots of writing, 7 beautiful marks. What have we got here? Well, we've got 11 days, and on each day he runs further, so the length of his 11 practice run form an arithmetic sequence with first term A, common difference D. So we don't know what those are. So he runs 9 kilometres on the 11th day. That is code for an nth term. So on the 11th day, he runs 9 kilometres. So 9 is equal to, and the formula I'm using, just to make it really obvious, is A plus n minus 1 D. So it equals A, which we don't know. We do know what n is, it's 11. So 11 minus 1 D. So what we've got there is 9 equals A plus 10D. And that's our first equation. But it's got 2 unknowns in it. 2 unknowns, we need another equation so we can solve for the 2 unknowns. So our second equation comes from this. This is a sum problem. So the Sn is equal to n over 2, 2a plus n minus 1d. So the total, that's the clue for it. So we know that the total, so that is 77, and it's over 11 days. So it's 11 over 2, and then we have 2a plus, and we know that n is 11, plus 11 minus 1, and we don't know d, and that's our second formula. Now, I'm going to solve by substituting in for a, which is going to give me an equation in d, which I can then solve. So I'm going to rearrange this for a. So a is equal to 9 minus 10d. And I'm going to substitute into here. So I've got 77 is equal to 11 over 2, and then it's 2 lots of 9 minus 10d. And then I've got plus 11 minus also plus 10d. Multiply the 2 across, so 77 doubled is 154, which is 11. Is that a wise idea? Possibly not, actually, because if I divide both sides by 11, then I know that's going to be 7. So if I divide that by 11, multiply it by 2, I get 14. So actually, I'm going to re-step there. And this is what you need to think about when you're doing your Core 1 exam, because it's a lot easier to divide both by 11, which gives me 7, multiply 2 across gets me 14. because you don't have a calculator. Then I've got, that's disappeared because it's all gone over here, and now I'm going to do 2 times 9, which is 18, minus 20d plus 10d, and then that gives me, if I subtract the 18, that gives me minus 4, and then on this side I've got minus 20 plus 10, which is minus 10d, and then I can divide it by minus 10, so d is equal to 4 tenths, which of course is 2 fifths. Now, if that's d, 2 fifths, then I can now find a, and I can do that using this formula here that I rearranged for. So now I'm substituting back over here. So a equals 9 minus 10 times, and I'm going to go for the 4 tenths for obvious reasons because they cancel, which means that a equals 5. And I've got my two solutions now, that and d is equal to 2 fifths. Now, you might be a little suspicious, like me, in which case you'd want to check. I'm not going to check both of them, but it's 9 kilometres on the 11th day. So on the 11th day, so I've got T11 is A plus N minus 1 D, which is 5 plus 10 times 2 fifths, which is 5 plus 10 times 4 tenths. They cancel, gives me 9, and of course if I was an exam I would substitute and check into the other formula, but I'm not going to because it's late. Alright, question 5, 17 minutes in. Anne's got some sticks of the same length, she raises them into squares, yada yada yada. Right, okay, so we've got a sequence here, we've got a 4, 7, 10 sequence. It's going up in threes, so the nth term rule for that is clearly 3n plus 1. You could have reached that, pardon me, that was basic GCSE, but you could have reached that using the nth term, which is a plus n minus 1 d, and you could have observed that the first one was 4, and the common difference was 3, because it's going up in threes. In which case you would have had this. You would have had the nth term is 4 plus n minus 1 times 3, which you should probably have simplified because it's useful to have a simpler version of it, and that gives you 3n minus 3, which works out to be 3n plus 1. So it doesn't matter which way you do it, you get the same answer. Now, B, find the total number of sticks. So, which formula is it? It's this one, it's the sum formula. 2a plus n minus 1d. Basically spot the formula this. Now what's A? A is 4, D is 3, and N is 10. Most of these questions are just plugging numbers into one of these formulas. So the total, the sum of the first 10 rows is 10 over 2 times 2 times 4 plus 10 minus 1 times 3, which is 5 times 8 plus 9 times 3, which is 5 times 8, now that's 27, and 8 plus 27 is 35, and 5 times 35 is 175, I believe. Let me just double check that. 150 plus 25, yes. Okay. Question 6. Trickier question here, the 25th term. So, you want the 25th term, this is an nth term problem, so yes, it's this formula. The nth term is a plus n minus 1 d. And you're just asking to get into trouble here really because there's negatives. A is obviously 30, D is obviously minus 1.5. You haven't got a calculator. What you're going to do, well, you're going to fill it into the formula. So t 25. Oh yes, n of course is 25, isn't it? So we've got is equal to 30 plus 24 times minus 1.5. How are you going to do that? Well, minus 1.5 is times 1.5. So first of all, it's going to be a negative number. 24 and another half of 24 is going to be minus 36. Because that's 124 and a half 24s, and that gives you minus 6. The rth term of the sequence is 0. Find the value of r. So we know that the rth term is 0. So that obviously is when n equals r. So we just, again, a is still 30, d is still minus 1.5. So we know that if this is 0, we've got 0 equals a plus r minus 1 times minus 1.5. Careful with that minus. So we've got 30 plus, now, minus 1.5r. Minus 1 times minus 1.5 is plus 1.5. And it's 0. So that is 0 equals 31.5 minus 1.5r. Add that over, we've got 1.5r. Try again. Is 31.5, and that implies that r is 31.5 divided by 1.5. But again, you haven't got a calculator, it's core 1. What do? Well, you unsimplify the fraction. Divide by 5, and you've got 3 5s on the bottom and 63 5s there, and 63 divided by 3 is 21. So the 21st term is 0. Now, the sum of the first n terms of the sequence is s and n. So telling you pretty clearly it's the Sn formula. Find the largest possible positive value of Sn. This is 3 marks for actually thinking about what this means. So let's go back to our sequence. It's got a common difference of minus 1.5. The 25th term is minus 6. So the sequence is getting smaller. Okay, it's starting on 30 and it's going down. And at some point it gets to 0 and then it goes negative. So if we add up terms, when we add this bit up, it's going to be positive. When we get to here, that's the biggest it's ever going to be, because after that we're going to start to add negative terms, and so the sum of the terms will go down. So, since we've already worked out that this is the 21st term, the largest positive value of the sum has surely got to be the sum of the first 21 terms. Or 20, should be the same, shouldn't it? Because the 21st term is 0. So what we want is the sum of the first 21 terms, which is given by 21 over 2 times 2a. A was 30, wasn't it? Plus n minus 1. D. D was minus 1.5, remember. So, we've got 21 over 2, 60, plus, well actually minus, isn't it? Sorry, my apologies, let's stay with that plus for the moment. Plus 20 times minus 1.5, and, pardon me, 20 times minus 1.5 is going to be minus 30. 21 over 2, and that gives us 21 over 2 times 30, which is the same as 21 times 15, because the 2 and the 30 cancel, leaving 15 there, and 21 times 15, cool, it's late, 21 and 15, 200, 100, 10 and 5, so 315. And there we go. And now we come on to our last question with Sue, who's training for a marathon. Okay. Every Saturday, starting with 5 kilometres. So what have they told us there? They've told us that A is equal to 5, and each Saturday she increased it by 2, so D is equal to 2. And this is on a particular Saturday, so it's N is 4, and it's the nth term. So it's the 4th term, and it's A, which is 5, plus N minus 1, D. So it's 5 plus 4 times minus 1, which is 3 times 2, which is 5 plus 6, which is 11 QED. We've just shown it. Okay. Now on the nth Saturday, so find an expression in terms of N for the length of a training on the nth Saturday. So we want to know what this is, and it's A, which is 5, plus N minus 1, D. It's not enough to it's not enough to write A plus N minus 1 D, because that's not specific to Sue, that's any arithmetic sequence in the world. Sue has got A is 5 and D is 2, so we can simplify it for our own purposes later on. So that's 2n minus 2, which is the same as 2n plus 3. And there are other ways of getting that, which are fine. Show the total distance she runs on Saturdays in n weeks of trainings is that. So, we know that Sue starts on 5, we know that her common difference is 2, and this is the total difference, so it's the sum formula. This is why it's done that. Okay, even more peculiar. So, is equal to n over 2, 2a plus n minus 1 d, which is n over 2, 2 times 5 is 10, plus 2n minus 2, which is n over 2, 10 minus 2 is 8, plus 2n, and then finally I'm going to divide through by 2, so I've got n, and then I've got 4 plus n, which I believe is the same as n plus 4, which is the same as n plus 4. And there we go, we've done it. That's your homework. Have a watch of that. I hope it was useful.